Okay, the division algorithm is not anything that's hard. It's just the quotient and the remainder. That's all you're looking at. So if you have two natural numbers and b is not 0, then there exist integers and they're unique. That exclamation point means unique, and the backwards e means there exists. Such that you can write this formula down, a equals bq plus r. Very innocent looking, but it's really important. You'll see that being used all the time. And you might have seen this in modern algebra, actually, and being used. It turns out, how many of you had modern algebra? The division algorithm, right here, this r, is the mod. So this is, when you're looking at, for example, things mod 2, the r is what tells you what that mod is. You're looking at the remainders after you divide by something. So it's pretty important. We already know what this is, the quotient and the remainder. If you're, I don't think anybody's taking modern algebra, but if you took modern algebra, it's probably the opening thing that you looked at depending on what book you used. So for example, if I have a equals 10, b equals 3, then 10 is equal to 3 times 3 plus 1. The r would be 1, the q would be 3. So what's the Euclidean algorithm, and what's the relationship between that division algorithm to the Euclidean algorithm? The division algorithm is used to prove the Euclidean algorithm, that you actually converge to the GCD. But I'm not going to prove the Euclidean algorithm. I'm going to prove you more things that similar to what you have in the homework. So, and I'm just going to show you how this works. So you use the division algorithm repeatedly to do this. So what you'll do is you'll take the two numbers, a and b, and expand it using the division algorithm. Then this b will come down to be the new a, and this r will come down to be the new b. And then you apply the division algorithm again to this pair, and again, these guys will move down. Like so. And you keep doing this process iteratively, forward in time like this, and until you get a 0 remainder. The last b that you get is the GCD. So you're going to see that with numbers in action. It's easier to explain with an example than it is to write out. And I thought it was hilarious because he was really trying to explain it with words. It was difficult for him to explain it with words. So I just took an example from the book, 578 and 442. So you take first 578, you divide by 442 on a calculator, it goes in once. You look at what the remainder is. The remainder is 136, so you expand out the first one. Then the 442 comes out here, and the 136 comes here. And you apply the division algorithm again to these two numbers. And you do it again. And what happens is, on this go around, I got a remainder of 0. Once I get that remainder of 0, I stop. And that's my GCD. Clear?